Welcome back. So in 2017, a team of researchers at Google published a paper saying attention is all you need. And they proposed an architecture that threw away years of established neural network design and single-handedly birthed the modern era of Gen AI, from ChatGPT to Claude. Today, we're tearing down the engine of the AI boom, the transformer. So we're talking about the transformer. So to understand a transformer, you have to understand the fatal flaw of RNNs and LSTMs. So they process data sequentially. To read word number 50, you have to wait for word number 49 to finish, right? You can't do it parallel, which means it runs horribly slow on modern GPUs. The creators of the transformer asked the radical question, what if we completely delete the RNN? What if we just take the attention mechanism, which in my last video I spoke about that, feed the entire sequence all at once and let it figure out the context in parallel. And it worked, and training speeds skyrocketed. The core of the transformer is a concept called self-attention. So in the last video I made, attention was used to translate like a French word to an English word. But in self-attention, the words in a single sentence look at each other to understand context. If I say, the barista poured the oat milk into the espresso, it steamed perfectly. What does the word it refer to? Self-attention mathematically links the vector for it directly to milk. And the transformer doesn't just do this once, it uses multi-head attention, meaning it runs this process multiple times simultaneously. One head might pay attention to grammar, another to the coffee vocabulary, and another to the emotion of the sentence. And it builds like a massive web of meaning. But deleting the RNN created a massive new problem. If you process all the words at the exact same time, the model loses all concept of order. To a basic transformer, add milk, then pour espresso looks mathematically identical to pour espresso, then add milk. Obviously, in a coffee shop, this order matters. To fix this, we use positional encoding. Before feeding the words into the network, we inject a tiny mathematical wave, like a unique pattern of numbers, into every single word vector. This acts like a timestamp. It gives the model a way to mathematically calculate the exact distance between any two words, restoring the timeline without sacrificing parallel processing. And here's some example of how it's done between sequence A and sequence B. Now, let's look at the decoder. When a transformer is generating text, it's predicting the very next word. But during training, we feed it the whole sequence at once. If we aren't careful, the self-attention mechanism will look just ahead of the future words and cheat. To prevent this, we use masked attention. We literally block out the future words with negative infinity in our math. This forces the model to actually learn the underlying patterns of language using only the past context, rather than just peeking at the answer key. And look, the craziest part is the architecture is so powerful that it's no longer just for text. We now have vision transformers, or ViTs, which take an image, chop it up into a grid of tiny patches, treat those patches exactly like words in a sentence, and run them through self-attention to crush state-of-the-art computer vision benchmarks. The transformer truly changed everything.